Hello and welcome back. This is Saxon Math, Lesson 38. It's Course 1, adding and subtracting decimal numbers and whole numbers, as well as squares and square roots. This is a long one, I'm not going to lie. There are 17 practice problems after the initial 5 examples. So we're looking at a healthy number of problems here. We're going to go really quickly. You'll just have to pause or replay if you miss something. New concept. Margie saw the sale sign in the clothing department. What is another way to write $3? So here we show two ways to write $3. You can have $3 with no decimals or $3 with the decimal. We see that we may write dollar amounts with or without a decimal point. We may also write whole numbers with or without a decimal point. The decimal point follows the ones place. Here are several ways to write the whole number 3. This is 3, this would be 3. This is actually not very common. I would actually say that's not really something most people would ever write, but that is 3. It still represents 3. This is 3, and this is also 3. We could go on further than that too, on to infinity. This is also 3. But again, this is not a common practice of something to write 3. As we will see in the following examples, it may be helpful to write a whole number with a decimal point when adding and subtracting with decimal numbers. So example 1, paper used in school is often 11 inches long and 8.5 inches wide. Find the perimeter of a sheet of paper by adding the lengths of the 4 sides. So in this case, when adding decimal numbers, you just have to align the decimal points so that we add digits with the same place values. So the whole number 11 may be written with a decimal point to the right so that you can be assured to line up the decimal points and add. The perimeter is going to be 39 inches, so it would look like this. If you have 11, so the reason why they write it like this is just to make certain you're lining up the decimal points. So as you line up the decimal points, you're adding the same value. So the ones place adds to the ones place, the tens place to the tens place, the tenths with the th place adds to the th place. So here you've got 11 plus 8 and 5/10 plus 11. And the reason why we put a decimal is just to make sure it's lined up. And then 8 and 5/10, if you were to add those together, you see that 5 plus 5 is 10. Decimal comes straight down in the answer. Carry the 1. Ignore, you don't squeeze the 1 in there. It goes over the ones place, the place value. So you have 1 plus 1 is 2, plus 8 more is 10, plus that would make 11. This would be 19. Carry the 1. Now you have 1 plus 1 plus 1 makes 39. Moving right along. Subtract 12 and 75 hundredths and 5. So you write the whole number 5 with the decimal point to its right. Then we line up the decimal points and subtract. So it should look like this. The decimal points lined up, and then you can subtract. You would notice that this could be 5 and 0, 0 after it still means that it's equal to 5. So if you have 12 and 75 hundredths minus 5, you have to make sure that you're subtracting the right place values. 5 minus 0 is 5, 7 minus 0 is 7. Decimal comes straight down in the answer, and then you have to borrow here to make this 12 minus 5, which is 7. 7 and 75 hundredths. So recall that we find the area of a square by multiplying the length of a side of the square by itself. For example, the area of a square with sides that are 5 centimeters long is 5 centimeters times 5 centimeters, which equals 25 centimeters squared. So the area within here is 25 centimeters squared. From the model of the square comes the expression squaring a number. we square a number by multiplying the number by itself. So 5 squared is 5 times 5, which is 25. To indicate squaring, we use the exponent 2, like this. This would be the exponent 2 up above. That is the same as 5 times 5, which equals 25. 5 squared equals 25. An exponent shows how many times the other number, or the base, is to be used as a factor. In this case, 5 is to be used as a factor twice. So 5 is the base, and 2 is the exponent. That's the same as 5 times 5. If it was 5 is the base and 4 is the exponent, that would simply mean 5 times 5 times 5 times 5, 4 times. If the base was 2 and the exponent is 5, that's the same as 2 times 2 times 2 times 2 times 2. So what is the area of a square with sides that are 5 meters long? So if it's a square and each side is 5 meters, what is the area? That's the space inside here. Area equals length times width. And in this case, if it's a square, it's the same as taking the length times the width. It's the same as 5 times 5, which ends up being 25 meters squared. And when you multiply meters, you've got 1 meter here, you got another meter here. It's meters times meters, which ends up being this as the label, meters squared. It's very important. The 5 times 5 becomes 5 times 5, just like 25, and then your label is meters squared. So we read 25 m to the second power as 25 square meters. Or you could say 25 meters squared, or and that's a couple of ways. We can use an exponent of 2 with the unit of length to indicate square units for measuring area. 1 centimeter squared is 1 square centimeter. It's the same way of saying it. All right. If we know the area of a square, we can find the length of each side. We do this by determining the length whose square equals the area. For example, a square whose area is 49 centimeters squared has lengths of 7 centimeters, because 7 centimeters times 7 centimeters equals 49 square centimeters. That's how you would read that, 49 square centimeters, or 49 centimeters squared. Determining the length of a side of a square from the area of the square is a model for finding the principal square root of a number. Finding the square root of a number is the inverse, which is the opposite. Inverse means opposite of squaring a number. So 6 squared is 36. That's as in 6 squared is the same as 6 times 6, which equals 36. The inverse of squaring is a square root. So the square root of 36 actually equals, and it's not a division sign, so the answer doesn't really go up here necessarily. The answer would be 6, because 6 times 6 will get you to 36. So we read square root of 100 as the square root of 100. This expression means what positive number, when multiplied by itself, has a product of 100. Since 10 times 10 equals 100, the principal square root of 100 is 10. A number is a perfect square if it has a square root that is a whole number. Starting with 1, the first 4 perfect squares are 1, 4, 9, and 16, as illustrated below. So you can see here that 1 times 1 is 1. So the square root of 1 is actually 1. Here you have 2 times 2, so like this length and this width right here, 2 times 2 is 4. That's the square root of 4 is actually 2, which is one of the sides. This one you can see that it's 3 times 3. So you've got the length and the width being 3, and the value of this would be 9 units squared. And if you were to square root 9, the square root of 9 is one of the sides, 3. Another perfect square is 4 times 4, which is 16. The square root of 16 equals 4. You could move on. 5 times 5 is 25. That's a perfect square. You could represent that showing a picture as well. You'd have to have 5 going across and 5 down and then fill in the blanks. You could have 6 times 6 is also a perfect square. That's 36. So a perfect square is what a number is if it has a square root that is a whole number. So the square root of 36 is 6. So that means 36 is a perfect square. 25 is also a perfect square because you have a square root of 25 equaling 5. All right, let's look at another example here. So simplify 64. 64 happens to be another perfect square. What number times itself will equal 64? 8 is the answer because we're thinking about there are 64 square units, and if you went 8 up the length and 8 on the width, you'd end up with 64 total squares inside that box. So with either approach, we would find that the square root of 64 equals 8, because we know that 8 times 8 equals 64. All right, so we've got a lot of practice problems here. Let's start with letter A, 4 plus 2 and 1/10. So let me set it up for you real quick. But it's 4 and 2 and 1/10. And that would be the only reason why I'd want to set this up with a decimal like that, is just to make sure I've got it in the right location. This would be 1. The decimal would be straight down in the answer. This would be 6. 6 and 1/10. Letter B, go ahead and do that one. So again, you should have had 4 and 3/10. This time it's minus 2, and the 2 is in the ones place. So that's where you'd have that. 3 minus nothing equals 3. Decimal still comes straight down in the answer, and this would be 2. So 2 and 3/10 for letter B. Letter C, 3 plus 4/10. This one would answer, the answer would be 3 and 4/10. I don't know if I need to show you, but I will. 3 plus 4/10 looks like this, because you have 3, so that 4/10 would be there. The decimal comes straight down in the answer, and there you go. Letter D, 43 and 2/10 minus 5. So again, this one would be 43 and 2/10, and you subtract the 5, make sure the 5 is in the right position. And you have 2 minus nothing, which is 2. Decimal comes straight down in the answer. I have to borrow here, so that changes to 3. This would be 13 minus 5, which makes 8 and 3. So you'd have 38 and 2/10. Letter E. For letter E, you have 23 hundredths plus 4 plus 3 and 7/10. Let me just write that over here. For letter E, so I'm going to start with 23 hundredths. I'm going to write in 4 in this position because it has to be under the 0. And then I need 3 and 7/10 in that position. We're going to add all those numbers. 3 plus nothing is 3. 2 plus nothing plus 7 is 9. And then the decimal comes straight down in the answer, and I have nothing plus 4 plus 3, which equals 7. So this letter E would be 7 and 93 hundredths. Letter F, and let me write letter F right here. You'd have 6 and 3/10 minus 6 wholes. Subtract that, there'd be technically there's nothing there. I'll just leave nothing there. So 3 minus nothing is 3. Decimal comes down. 6 minus 6 is 0. So you'd have 3/10 for letter F. Letter G, that's 12 and 5/10 plus 10. So for letter G, let me just write that here. 12 and 5/10 plus 10, making sure that the 10 is in the right place values. So I have 5 plus nothing, which equals 5. I would have 2 plus 0, which is 2, and 1 plus 1, which is also 2. 22 and 5/10. Letter H. Let me put letter H right here. 75 and 25 hundredths minus 25. So I'm going to subtract that. There's 5 minus nothing is 5. 2 minus nothing is 2. Decimal comes straight down in the answer. 5 minus 5 is 0. 7 minus 2 is 5. So you'd have 50 and 25 hundredths for letter H. All right, letter I. This is a square. So this just means 9 times 9, which equals 81. Letter J, the square root of 81. Wow. If you don't know that one, just look at letter I. The answer would be 8. Letter K. If you have 6 squared plus 8 squared, you have to do please excuse my dear Aunt Sally, which means you do parentheses and exponents before you do addition and subtraction or multiplication and division, all those things. So parentheses and exponents, so I'm going to do exponents first. That means this translates to 6 times 6, which is 36, plus 8 times 8, which is 64. And now I have to just add those together. I'd end up with 90 plus 10, which makes 100. Letter L, the square root of 100 minus the square root of 49. So again, you need to do all of the things, parentheses, please excuse my dear Aunt Sally's, parentheses, exponents. That includes square roots, by the way. So if I'm looking at letter L, I need to make sure that I break this down into the two parts. I've got, this would be 10, because the 10 times 10 equals 100, minus, in this case, 49 would end up being, I guess this would be 7, is what I was thinking. So you'd have 10 minus 7 equaling 3 for the answer in that one. And letter M, 15 squared. That just equals 15 times 15. So in order to do that, I'm going to show my work over here. 15 times 15 would be 25, carry the 2. This would be 5 plus 2 makes 75. This would be 5, that would be 1. Add those together, I've got 5, 12, 225 would be the final answer to 15 squared. And letter N, 144 is square root of it. Now, if I don't know what that is, I have to just guess and check. I know that if I have 15 times 15, it's 224. So it's got to be less than 15, and it has to be more than 10, because I know what 10 times 10 is, 100. So I'm going to shoot for somewhere in the middle of those, because that's kind of in the middle range. I would say between 10 and 15. Let's try 12. Let's try 12. Let's just see what 12 does. 12 times 12 is the same as 4. This would be 2. This would be 2. This would be 1. So I'd end up having 144. I got it right on. First guess. Now, if I didn't guess 12 to begin with, I would just have to try another number. It could be 11, or it could be 13, it could have been 14. You don't know until you actually work it out. So 12 times 12 equals 144. Therefore, the square root of 144 is 12. Letter O, 6 times 6. So, 6 feet times 6 feet. So I have to make sure that I'm multiplying this 6 times 6, but I'm also adding to that I'm multiplying feet times feet. So in the answer to this, I've got the numbers. That's pretty easy. I know that's 36, but my label needs to be feet squared. the exponent in the answer should be feet squared. Letter P, 64, the square root of 64 meters squared. So I have to do both of these, the square root of both of those things. I know that the square root of 64 is 8. 8 times 8 equals 64. And if I have the square of m, remember the inverse is the square root, which just makes this m. Okay, because this would be like 8 meters times 8 meters, which is the same as 64 meters squared. So you see that the square root of 64 meters squared is actually 8 meters. And letter Q, it says, starting with 1, the first 4 perfect squares are as follows: 1, 4, 9, and 16. It asks, what are the next 4 perfect squares? So what's this one, this one, this one, and this one? I need to know the next 4 perfect squares for this answer. So remember, this is 1 squared, this is 2 squared, this one is 3 squared, this is 4 squared. 5 squared, you might know the answer to that right off the top of your head. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. And 8 times 8 is 64. So those would be the next 4 perfect squares. And if you were to label them, or if you were to show them as they might read, it would simply be 5 squared, this would be 6 squared, this would be 7 squared, this would be 8 squared. All right, that wasn't too bad. We were able to finish it in pretty good time. Thanks for watching and finishing all of your practice problems, and I hope you learned something. If you didn't, rewind, review, and we'll see you tomorrow.